All right, we're talking about how we create a sampling distribution. And we started by making samples of size 2 out of a population of 4 values. And we found the mean of each one of those samples. Then we took each mean and found the probability of it occurring by taking the number of times it occurred up in number 1 and dividing that by 16, which was the total number of samples we had. So now let's look at the means. Let's find the population mean. So going back to our original population, which is just 179, 111, 85, and 74. And we can do that by putting those numbers in our list. And I am clearing out what's in there already. So we need to put 179, 111, 85, and 74. Now, hopefully everybody remembers we go second mode, and then we go to stat, and over to calc, and pick the one var stats when we need to find the mean. Now, in this case, we only have stuff in list 1. We don't have any in list 2, so we need to make sure that that's cleared out. And when we tell it to calculate, we get an X bar of 112.25. Remember, X bar is our mean. And remember, we're treating these 4 values as a population. So normally we pick SX because we have a sample, but this time we have a whole population. So we want to take the population standard deviation, which is the sigma X, which is 40.81, etc. So we're going to go ahead and we're going to write down the mean, which is 112.25. And we're also going to, while we're at it, write down our population standard deviation, which was 40.81283499. Notice it says do not round the answer. So now we need to go back and find the mean of the sampling distribution and the standard deviation of the sampling distribution. So to do that, we're going to go back to number 2 where our sampling distribution is, and we are going to get the calculator. And we'll go back to our lists and clear out list 1. So this time we need to put all the X bars in list 1 and all the P of X bars in list 2. And I'm going to stop recording while I do that because I don't think you need to see it. Okay, now that I have gotten all of the sample means and their probabilities in list 1 and list 2, I go second mode to quit and then stat over to calc, one var stats. This time we have values in list 1 and we have probabilities in list 2. So in frequency list, we need to go second and the number 2 button to put L2 back in there. And now let's calculate. So one thing you'll notice is that this time it gave us an X bar, a mean. It did not even give us an SX, which is our sample standard deviation. That's because when we have that L1 and L2, remember, the calculator says, oh, this is a population. We have all of it, so it only gives us the sigma X for our population standard deviation. So let's go write those down. And I must have mistyped something because our X bar should have worked out to be the same. So let's go see what I mistyped. Okay, you can see here that I typed my first entry wrong. It should have been 179 instead of 175. So I'm just going to fix that by typing back over it. Now, let's try this again. There we go. So, for our mean of the sampling distribution of the mean, we got 112.25. So what's the relationship between those two? Well, they're the same. And that's always going to be true. The population mean is always going to equal the mean of the sampling distribution of the mean. Now, for our standard deviation for the sampling distribution, or the standard error of the mean, we got 28.85903,238. So by definition, the standard error of the mean should be the population standard deviation divided by the square root of the sample size. So let's see if that's true. So our sigma sub X bar should equal 40.81283,499. And how big were our sample sizes? All of our samples were of size 2. So let's go put this in the calculator. Let's see if I go, there we go. So I'm going to put 40.81283,499 divided by, now to get the square root, it's right here above the X squared button. So we need to hit the second key and then the X squared button and then the number 2 to divide by the square root of 2. And if we hit enter, what do we get? We get 28.859 03238. 03238. So that's true, right? Because here's what the calculator told us, and we said that should be the population standard deviation divided by the square root of our sample sizes, and it was. So that's how the sampling distributions of means are created. Just so you have an idea of what's going on. Now, we'll talk about how that is applicable to the statistics we're talking about in the next video.